What I'll try to do today with this workshop is help you understand what data visualization means and how you can use it in order to show data in a manner that makes sense to your users. We definitely live in a world surrounded by data, but we still fall short when it comes to showing it in the right manner. And basically, it's not a matter of technology, it's a matter of how we use that technology in order to show the data. Okay, let me show you the agenda. So we'll have an intro with a setup and a test. You will need your mobile phones because we'll have live polling throughout the presentation. I'll show you a little bit later how you can connect. We'll start with test your current knowledge on visualization in general, and then we'll go through a learning process because basically, just like anything else, data visualization is somehow a science and it needs to be learned. And at the end, we'll consolidate that knowledge by testing your knowledge again to see if you've learned something during the presentation. And we'll have a contest at the end, and the winner will receive a gadget. Okay, let's start with the setup. Like I said, please open your mobile phones. You can either scan this QR code or open any browser and go to that URL. As you connect, I'll let you know the next steps. You'll be asked for a name. You can choose to enter your real name or be anonymous, I don't know, enter anything, or be creative. But keep in mind that I'll have to know to which person to award the prize to at the end, so it might be helpful to know your name. Preferably don't use just your first name, because that might create confusion at the end. I won't know who to award the prize to. Okay, here we'll see as people will connect to it. It's pretty hard to make an estimation of how many people are in the room. I would say about 40. But yeah, let's wait for people to connect. Sure. It's pretty interesting that we don't have such a large crowd working on machine learning AI. So it's definitely a hint into what machine learning and AI is, meaning, let's say, a newer technology, and people try to shift towards that, and you're all interested in it at this point. Okay, so this is some kind of data visualization, right? So I can see all the values, all the occupations that you have. But of course, it's not shown in a okay manner. It's the same as looking on a table and trying to make sense of that data. There are too many values. These aren't grouped by any sort of thing. So after this workshop, you'll understand why such a visualization doesn't make sense. Okay, let's do one more test. This one is about your knowledge, your current knowledge before coming to this workshop. You'll be shown, at each question, you'll be shown a chart, and you'll have 3 options. The question is the chart used correctly? You'll have 3 options: yes, not optimal, or no. Yes is if the chart is used correctly, so the right type of chart for the right type of data. Not optimal means the chart is the one desired for that kind of data, but maybe the colors aren't used correctly, maybe the labels aren't correct, and so on. So minor things that might influence the way that chart is read. And the last answer is no, so I wouldn't use that chart for that kind of data. Are you ready? Okay, you'll also have a timer, so it's 30 seconds for each question. Let's look at the first chart. Is it used correctly? The title here says, Immigrants as percentage of population in 2016 by period of immigration. The colors here represent the year the persons who immigrated came into US. Okay, so 71% of you said not optimal, only 17% said no, which, by the way, is the right answer. Now, why it's not optimal? It is because we actually have a time series here. So we have before 1981, 81, 90. So this would have been better shown on a line chart. But I won't go into all the details for each chart, as we'll cover that in the next section, and you'll realize why the answer was correct or not for each question. Okay, let's go to the second one. So 81% of you answered correctly. Congratulations, this is really good news. Yeah? Okay, next one. Okay, let's see the answers. Not optimal, 59%. This looks pretty good. It seems lots of you have worked with data before, or you just use your common sense to guess the answer or to actually know it. Let's see. Okay, so lower percentage this time. And the last question. Okay, let's see. The correct answer is no. This is, I would say, it's quite obvious. It's quite weird to use a pie chart when the sum of the values is not 100%. You'll later see that pie charts are usually used for part-to-whole relationships, so the total should always be 100%. Let me take a note. Okay, so the average for this test, so the average rate of correct responses was 42%, which I would say is pretty good, since we haven't dived deeper into the knowledge yet. Okay, and let's see the leaderboard. So Alex Lukian was the best at this contest, followed by Niklas and Julian Prodan. Okay, this wasn't the contest for the prize, you know. We'll have that at the end. Okay, this is just a baseline to see where we stand at the beginning. Hopefully, at the end, we'll get better. I won't guarantee that at this point. Okay, there's a process in creating a visualization that makes sense, and the process is usually divided in 4 steps. First of all, start with questions, then choose the right chart, then create an effective view, and then combine those views into meaningful dashboards. Let's start with the first one. Start with questions. These are some questions that might help you understand what you're trying to say, who is your audience, and help you in this process of, okay, what kind of data should I show? First one, what are you trying to say? Pretty obvious. You should know what you're trying to say before trying to say something. Next one is, who is your audience? I would have put maybe this first, because it's really, really important. So you know what you're trying to say, but you have to know who will read that chart. And there's a famous example, probably all of you heard about it. The confusion between Bucharest and Budapest. It all started in 1990 when Michael Jackson came at a concert in Bucharest and was really excited and said, "Hello, Budapest." Okay, right? That's not the way to do things. And many others followed afterwards. Iron Maiden, more Chiba, and so on. They've continued the trend by saying out loud, "Hello, Budapest," in front of thousands of Bucharest inhabitants. That's quite odd to say that, right? You might lose the crowd from the start. If you're Michael Jackson, it wouldn't matter. They will be okay. But otherwise, you might lose them, and that could be a big issue. Therefore, when Iron Maiden came back in Bucharest the guys from Rome, the chocolates, had this campaign throughout the city. Hello, Bruce, who's one of the guys singing at Iron Maiden. Kind reminder for tonight, it's Hello Budapest, Hello Bucharest, not Budapest, right? So yeah, pretty funny. It's the same with data, right, and data visualization. And basically any other area when you show something to an end user, you have to know who that end user is. Is it a data scientist? Is it a data analyst? Is it an end user who has no idea, no deep knowledge on data? So you might want to help them and guide them through reading that chart, visualization, whatever. Other questions. What questions do they have? Really important. We need to answer people questions, even if we don't know those questions. We have to imagine what kind of questions would they have. What answers can you find for them? Of course, answers to those questions. Really important, what other questions does it inspire? Because when you show a visualization, it inspires, right? And people might see something and say, okay, but what about that? What about that? And so on. And a visualization can start a conversation around data. So what you want to say and what people are interested in might be completely different. The key is to find that common spot called relevance, which maps these together. The key point is that your viewers should take something away from the time they spend with your visualization. Like, don't make them look at the chart and say, oh, okay, I've lost my time by looking at this. After you've asked yourself all those questions and found the answers to them, you need to choose the right chart for showing that data. And we'll go through examples of scenarios that are most commonly encountered and what kind of charts make sense for those. First one is trends over time, right? Trends over time is whenever you want to show a metric throughout a time period. Years, months, days, whatever. The most commonly used chart for this scenario is the line chart, famous line chart. For example, here I have the tourist income by region. Each line represents a region. It's color-coded such that I can see which region I'm looking at. And the key point here, since we're talking about trends in time, is to understand the shape of the data. Has the tourist income increased? Has it decreased? Can we find periods when it was, the trend shifted? Like here in 2009, where we can see that for all regions, tourist income has decreased. And we all know that this was the time with the crisis, right? The financial crisis. Then regions started recovering and continued to grow. Overall, it's an upward trend. It can be easily seen even without reading the axis or any kind of values here. We can see that over time, since 2000 till 2012, tourist income has increased. But let me ask you a question. If we're looking at 2011, which is midway between 2010 and 2012, versus 2012, I can see that for Europe, tourist income has decreased. For Asia and the Americas, it has increased. Africa seems flat. My question for you is, how about overall, at the global scale, has the tourist income increased or decreased? You can't figure it out from this chart. And that's one downside of this type of chart. Of course, let's go again to ask the questions. Do I want to show the trend for each region in order to compare the regions and the trend for each? Or do I want to show the total? I'm not saying this chart is correct. It's perfectly correct. But if the question differs, this doesn't work anymore. And if we're talking about the total, you might want to use another type of chart, which is the stacked bar chart. Now, I can easily see that the trend, globally, and I can see that in 2012 versus 2011, the tourist income overall has increased. But this kind of chart also has downsides, because I'm losing the ability to compare each individual region over time. I can do it easily for Europe, but I can hardly do it for the Americas. For example, is tourist income higher in 2007 or 2008? Pretty hard to tell the difference, because the bar chart doesn't start at the same level. Here I can easily see 2008 was higher than 2007. Okay? So if you want to look at the total, you might want to choose this one, but you lose some details regarding each individual region. There's another interpretation, I would say, about for the stacked bar chart, which is the area chart. It comes somehow with the same limitations. Again, really nice to see the overall value, hard to compare the individual regions. But here, indeed, for 2006 versus 2007, or sorry, 2007 versus 2008, I might see that the angle here is smaller than this one, and I would say it has increased. But that's just mostly a guess. What you can also use is a line chart, again, this line chart, with a total, which is the gray line here. It actually uses a dual axis, so I have the axis for the total on the right. Keep in mind that this might be misleading, because I'm saying that the total is somewhere between Europe and the Americas. People might think that. So keep in mind to give users some visual indicators, like the shadow on the axis, to know that, okay, this line is for this axis. And again, you can put it in the legend as well. You can have the gray color with the total, same total. Okay? Now, another scenario is when you want to show, when you have two time dimensions. For example, here we have the days of the week and the hours of the day. For that, you can easily see you can easily use a heat map, which highlights the, let's say, if we're talking about the restaurants, which are the busy hours of the week, right? I can see that here between 8 and 9 p.m. I had the most customers, and Tuesday, Wednesday, Thursday, Friday, Saturday, and actually Saturday and Sunday are the busiest, right? Because if you look at the whole region here. So it might work, just keep in mind what your question is. Really important here, you'll see these slides throughout the presentation, forgot to mention that. These are, let's say, the things you should take away with you, right? The key points that you should always have in mind when building a visualization. So choose the chart depending on what you're trying to emphasize. Now, comparisons and ranking, this is quite a simple one. You want to compare stuff between them, so different dimensions. I mean the same dimension, different categories, sorry. One example is the one we had in the quiz, CO2 emissions by regions. I have vertical bar charts. This is a comparison. I can easily see that Asia is higher than Americas, then Europe, and so on. I would order this one to be easier to understand. Preferably, you would order the bar charts when you do a comparison. Another way of showing ranking or comparisons is to use a horizontal bar chart. Again, pretty easy to see which is on the first one. Using these bar charts also helps you create a sense of volume. So I can see United States is approximately 1/3 of India in terms of population. Always use bar charts for comparisons and ranking. Trust me, others don't really work. You'll see later. You might also want to compare a metric to a target or a prediction. And let's say you have the revenue this year, and you want to compare it to a target or to previous year. This is a really interesting chart. It was invented pretty recently by Stephen Few, and it's called the bullet chart. It's a bar chart with a mark here. So you can see the actual value versus the target. This is really useful when you try to see if a target was achieved or not. And it can also help you to see the actual volume. You can maybe add a label here to say 275. One thing is that you need to educate a little bit the people to use this kind of chart, but once they get the hang of it, you can use it really easily. you will also see the background here, dark from dark gray to light gray. You can use that to encode quantitative ranges. So I can say, this is bad, this is satisfactory, and this is good. As you can see, it occupies really a really small space of the screen, and I can use many of these in a dashboard. These allow me to see really quickly, am I on target with the revenue? Yes, I'm over target. Profit, I'm under it. Average order size, oh, so bad. New customers, not that good, I still have to work on it. Customer satisfaction, good. On the right side, you'll see swapped version of this, so it's just vertical instead of horizontal charts. It's definitely the same story. What you can also do, but not in this case because you already have a background here, is to color code the bar values, the bar charts, to show if it's above or below the target. When I'm looking at this, I can definitely see that 2 of my agents haven't met their target yet. Okay, I might want to do something about it. And the others have met it. So whenever it meets the target, it's a color. When it didn't meet the color, a target, it's another color. So yeah, bullet charts, really useful. I definitely encourage you to use these when you want to compare a metric against a target. Or a prediction, or another time frame. Like I said, you might want to compare this year to previous year, this month to previous month, and so on. Okay, let me go back. So part to whole. Whenever we're thinking about part to whole, we all have in mind the famous pie chart. I really hate it. I'll tell you why. So over 50% of the time I see a pie chart used, it's not used correctly. Therefore, I really encourage you to stop using the pie chart. There are some scenarios on which you can use it, but there's a higher chance that you will use it incorrectly. Let me tell you why. World population. Okay, so I have the pie chart with the whole world population. I can see I have a huge slide here. Okay, so somewhere in the world is more than 50% of the population. Okay, so I need the legend to know where. Just imagine the entire process of looking back and forth from the chart to the legend in order to see which values corresponds to which. And let's say I'm trying to compare Africa with the Americas. Which slide is, which one is higher? Which one has a higher population? Can you guess? You might say Africa because you might thought these slices are ordered. But are you sure about that? Maybe the one who created it hasn't ordered the values. So you also need labels on it. So indeed, Africa is higher than the Americas, just slightly. So lots of information, lots of space, lots of cognitive reading. So you have to read one thing, then go to the legend, and so on. And usually you don't even have enough space for the smaller labels, for the smaller slices. Right? I have a really small slice here, Oceania. I know it's 0.5%. I don't know how much is Middle East. You can try and do some workarounds to show somehow that data. Now, another interpretation, I would say, of the pie chart is tree map. Tree map, I've seen it a lot in the last years. It somehow has the same limitations. It's quite hard to compare surfaces, right? So I have to compare this section with this one. The only thing that it's helpful is that I can, like on the pie chart, is that I can know this one is more than 50%. So I know the majority of the data falls into that category. Another one is it's a stacked bar chart combined with the tree map, I would say. When you just have one bar chart and you have all these values, again, it needs the legend or a label here. It might work in some cases, like for the pie chart, when I could say you could use it, but only when you have a maximum of 3 values. Let's think about male-female comparison, right? If you have a gender comparison, that you can use the pie chart for that. But there are better ways of doing it, like this one, because you can easily see which one is higher. What I would suggest you is to use a bar chart for it. So I have the values for each region represented as a bar. And these are pretty easy to compare. I can see this one is higher than this one, this one is smaller, and so on. I also have the labels here. It's pretty hard to look at it and understand it and compare it, because that's the most important thing when you think about part-to-whole relationships, to compare slices or categories. The only limitation with this one is that it doesn't induce you the idea that we're talking about the part-to-whole relationship. The only hint is that you have percentages here, and you might think, oh, okay, the total is 100%. But you can fix that by just adding a subtitle or adding that information in the title. So world population, percent of total by region. I have read the title, I know what the chart means, I can easily compare them. And I can even lose the color, because if you think about this visualization, the only reason the color is used is because I have to somehow compare this and differentiate this, and I have a legend. Here, I don't need the legend because the color doesn't mean anything. I mean, why would I use blue, light blue for Africa? Doesn't make sense, and you can't actually think of a color that would represent a region, and that might be also wrong to do that, okay? So, world population, total by region, I can easily compare these and see that we're talking about the part-to-whole relationship. And once I get this, it's pretty easy to see. Okay, so my tip here is to try to avoid pie charts or donut charts, because those are actually a pie chart with a hole in the middle, same thing. Or any other tasty charts, try to use protein bars, right, are better and healthier. Okay, a more complex scenario is when you have correlations, meaning you want to see the correlation between two metrics. I'll show you an example. This chart might look a little bit crowded at the start, but let's try to understand it. On the bottom axis, I have the internet coverage, so what percent of people have access to the internet. On the left side, I have what percent of people live in urban areas. Each circle here represents a country. That's it. So we have lots of countries here, and the color represents the region, and the size represents the total population. If I'm thinking about comparing internet coverage with urban area, I don't actually need region and population total, so I could just leave some dots there, right, with the same color. But in this case, it might tell you a story, right? So as internet coverage increases, country goes from left to right. Here we have the countries with the most internet coverage, and here we have the ones with the least. As the circle goes from bottom up, the number of people living in urban areas increases. What you can see here is that all the points are in the same region. Just imagine a diagonal here. So they are here, all of them. So I can say as internet coverage increases, also does percentage of people living in urban areas. However, keep in mind that this is a correlation and it's not a causality. You probably heard about it. So we can't say that, okay, the fact that that internet coverage increases, more people go to live in urban areas, as well as you might say, okay, as we have more people living in urban areas, those areas are covered by internet and we have better internet coverage. It might be the case, it might be not, it's just a correlation. You might want to test for that causality and check other variables. What's interesting about this, since I've used these colors for regions, is that I can see that Africa, which is lighter blue, most of the countries in Africa have a low population living in urban areas and low internet coverage. If I'm looking at Europe, most of the countries are here. So it shows me like a picture of the world of how the countries are spread. Let's go to another example. You want to compare the sales price with the quantity. I have the quantity on the bottom axis, sale price on the left axis. I can see that as the sale price decreases, the quantity increases. And it's valid for almost any e-commerce website or any business, let's say, right? Products with a lower price usually sell in higher quantities, right? You can imagine that. You also have this trend line here, which shows you the correlation between the two, and you can also get the formula for it, so you can think about what the correlation is. Each data point is basically a product here, and we have the net profit for it as a size. Just like in the example before, what you'll see for these charts, so these are called scatter plots, is that you can't include a time dimension on it. So you don't know how things evolved over time, or if there is a correlation over time between these variables. What you can use in order to do that, so if you do have a time dimension and you want to highlight that, is to use what is called a combo chart. So basically there are multiple charts stacked together. I have a line chart for the sale price, one for the quantity, and one for the net profit. I can see that as the price increased, the quantity decreased. That's it. So, like I've said, scatter plots work best when you don't have a time dimension. Otherwise, you can use combo charts. Distribution. Distribution is when you're trying to see somehow the shape of the data. So it's somehow the same as when you're trying to see a correlation. But this time, one of the metric is always the volume, right? If I'm looking here, is the distribution of men's and women's incomes in 2016. I can see that most of the women fall here, males around here, so I can get a sense of the shape of the data. That's the whole purpose of a histogram, as it's called, to show somehow the shape of the data and how the values are distributed across the data range. I've also seen examples like this of a histogram where people try to get creative with them, and this is definitely a don't do it this way. Why would I put this on a radial chart? And if I want to compare this one with this one, it's almost impossible for me to do it. So don't try to be creative when it comes to data visualization. Another example for showing distribution data is Box-and-Whisker, it's called, so because it has a box here and some whiskers here and here. This is really useful, for example, when you try to compare A/B testing. So you have each user as one dot, so each run is one dot, and you try to see the differences between them. But let me go back to this example. These are two tests ran on the database. One was with the current implementation, let's say current query, and then we've tried to change the query, optimize it, and we had a different run. So each circle represents a test run, and I can see at its best, the first test executed in around 19 seconds. At its worst, it was over 100 seconds. And all the values between them. The average is 62 seconds. Here I had 15 seconds at its best, and 40 seconds at its worst. The average was 26 seconds. You might have already heard this, that average doesn't tell you the complete story, because average is highly influenced by outliers. That's why the Box-and-Whiskers chart introduces median as a default thing to see in the visualization. Median is actually where the darker gray with the lighter gray intersect, so this line here. Now, the median isn't affected by outliers. This is not I would say it's a very good example of comparing the average to the median, because we don't actually have outliers, because those would have been outside this chart. Here is an explanation of what the Box-and-Whisker charts means. So, like I said, we have the median here. 50th percentile. Then the box represents the region between the 25th percentile and 75th percentile. What I'm actually saying is that in this area fall 50% of the values. Just like the median represents 50% of the values. So I know that 50% of the test runs ran in less than 58 seconds. 50% of them ran more than that. The whiskers are basically the way of identifying outliers. So whatever values are outside those whiskers are outliers, so they influence the average, but they won't influence the median. This is a calculation. There is a calculation for choosing this whisker. Many of the reporting tools create this automatically, or you can even edit the way you want to use the whiskers. It's usually for example here, 25th percentile. I'm adding another half of the population here and use the lowest data point for it. I strongly encourage you to use Box-and-Whisker plots, but keep in mind that users need to be educated on it, on how to use it. So you might want to add a legend and help readers understand it. It's really useful when you show the data to a data scientist, a data analyst, but not so much when you're talking about a user who doesn't have a knowledge around data. Geographical data, this is pretty simple. You want to show a metric over countries, let's say, or cities, or continents, or whatever. For example, here I can see the GDP growth in 2009, where, again, there was the financial crisis, so most of the countries are with red. They decreased their GDP. Really useful to see the entire picture and maybe see which countries better or worse. The limitation is that it's quite hard to compare the colors, right? To see even on this screen, right? I can see it perfectly on my my laptop screen, but here the differences in hue, in contrast, are a little bit hard to see. That's why I suggest you add other charts beside the geographical map, besides the map, in order to show details about that data, even if it's a table with all the values for all the countries, because users might want to go and read each data independently. Here, for example, I have the top 5 countries, worst 5 countries, so the countries who were hit the most by the financial crisis, and I also have an average across Euro area. I'm comparing with other countries as well, like Japan and United States. So please pair maps with other charts for details or context. Number callouts, let's say you have a metric, I have the total sales this year, I want to show that number. That's it. Sales this year, $733,000. Is this good? Is this bad? Think about it when you show a number, just a number, to a user. This doesn't tell me anything. It's just, okay, I made this much money. Make sure you provide context. So, sales this year compared to last year. So, plus 21%. Okay, now I know. I'm doing better. You can also add color into it, so you can see the difference if it has increased or decreased. And you can also truncate the value, because I might not be interested in the last cent here. I want to know the whole picture. $734,000. What I've also seen, and I do recommend using, is more context. So just like we had here, we had the average check value, $75. So for a restaurant, on average, people pay at the restaurant $75. It's minus 2.3% compared to the last period. And I have here the last 7 days, so I know if it has evolved or not. This is called the spark line. It's basically a line chart without any axes or labels. It just shows you the shape of the data and helps you understand the primary metric better. So it gives you context again. This is another example from Twitter. You have the actual value, the comparison, the context, and again a longer period to see if you went up or down, right? I can see that followers have increased. Just keep in mind that you might want to explain what this period means, because here I don't know what the period is. It might be 30 days, it might be 1 year, I have no idea. So it might be useful to add some clues either in the title or as labels here. So make sure you supply adequate context for the data. Now, I've shown you what type of charts to use. These are, let's say, the primary charts that make sense. There are many other examples. You might want to read a little bit of what works and what doesn't for those charts. There are some more, but these ones that I've shown you should work for any kind of scenario that you have in mind. Now, after you've created the chart, you want to create an effective view, so to somehow improve that chart. And please prepare your phones again. Let me go back, actually. So, yeah. Just click the refresh button in the browser in case it hasn't refreshed already. And you should see this on your screen, hopefully. Okay, you can all see it. So the question is, you have this string of values. How many times does 5 appear in the string? You can probably use this one as in your phone. It will be too small to read. 41, 42, 43. Oh, okay. Okay, let's see. So 29, oh wow, that's a pretty nice distribution. 29% of you have said it's 5 times, then 6 times 23%, 4 times 17%. Okay, I won't tell you the answer, but I'll ask you to try again. Okay, let's see. Okay, people still got it wrong, but it's only 6%. That should be fine. So yeah, the correct answer is 6 times. 93% of you answered correctly. What's the difference between the first thing that I've shown you and the second one? Why were you able to get the answer better and I bet faster? The difference is what we call pre-attentive versus attentive processing. Attentive processing is when you actually scan a sequence of numbers or any kind of thing to see what's the to check what are the differences between points in that area. Pre-attentive processing is actually part of our brain, and it somehow triggers a reaction in our brain that, okay, that one is different, that is different, even without scanning an entire string. So I don't have to consciously check each value in the string. And this is the case with contrast, right? So contrast is a pre-attentive attribute. By highlighting these numbers, I've actually triggered a section of your brain saying, okay, these are different. I'll focus on those ones. And then I'll start numbering. So it's pretty easy to highlight, to count. Now, you might want to use these pre-attentive attributes in your favor. And this was one example. I'll give you more. So whenever you want to highlight or get people's attention to something, you might use these attributes. And there are many of them. We have orientation. I can easily see that this line is different from this one. Length, just like in bar charts, right? I can see the length and compare it. Width, I can see this one is larger. And so on. Size, shape, curvature, added marks, enclosure, contrast, color, position, spatial grouping. These ones refer that I actually think these ones are together, these ones are together, these ones are together. Now, if I were to think about the previous example with the contrast, and we have it here, can I say how much better is this circle compared to this one? It's quite hard to give a sense of quantity about some of these. And here is the list that might help you out. So if you're talking about, we're talking about color and hue, right? The difference in color between two values. These are definitely not quantitative. Meaning I can't say that red is better than blue. Why would that be? Or green is better than yellow, right? I can't use that. Intensity, like this one, or contrast. It is quantitative, because I can say, okay, this one is higher than the other, and I can add one more value between them, right, with a different color, not a different color, a different contrast, right? I can see the sequence of things. But it's limited. It's pretty hard to imagine how much better is one compared to the other. If we're talking about position, it is quantitative and so on. Again, for the added marks and enclosure, I know these ones are different, but I don't know, is that better? Is that worse? I have no idea. And let's try another test, let's say. Again, please open your phones. How much bigger is the second circle, this one, compared to this one? Okay? I'll try to go to the next slide. Hopefully the correct answer will appear. Yeah. So it's 16 times larger, 16 times bigger. Again, I've heard you ask the question if we're talking about area or radius. That was a good question. But keep in mind that you don't provide that information when showing this. So these were part of the pre-attentive attributes, the size. I can definitely see this one is bigger, but it's quite hard to add to talk about quantity there. How much larger is it? And the key point here is that people tend to underestimate differences into the areas. As you've seen in the results, only 40% of you chosen the 16x, and 62% of you answered with a lower value. Now, there are some other tricks that might help you. I'll go quickly through these ones, but keep them in mind. First of all, make sure you orient your views for legibility. Don't make me turn my head in order to read your chart. So just change it this way. Avoid overloading. Again, don't use too many shapes, colors, any other visual clues in the same chart. Try to slice them up or separate them into different charts. All that glitter is not gold. Keep it simple. Keep this in mind with keep it simple whenever you're trying to create a visualization. Can I read this? It's almost impossible. So limit the number of colors or shapes within a chart. In this chart, you can see actually that I'm using the same color for the same country, as there were so many of them that I didn't have enough values to use. It's enough colors. So this might make sense, this one doesn't. The rule here is to use a maximum of 7 to 10 colors or shapes in one view. If not possible, break those into charts, into separate charts, and use interactivity to filter between them. We've already talked about this. Don't display excessive details or precision. Now, this is a list of countries with their population. I can see the population for each one of them, but does it make sense to say, let's look at Romania, 21 million, this was as of 2010, 21,084,956. This might have already changed that 6, right? Even if we're talking about the live number, because people die, people are born, and so on. So it really doesn't make sense to use all that detail or precision, right? So what I can do is put 82 million, 21 million. That's more than enough. These values change anyway. So keep that in mind. Don't try to put the entire number if it doesn't make sense to do that. And of course, I can order this to give a better sense. I can now see that Romania is the 4th in the list with 21 million. Now, really important is to choose the correct measure in order to highlight what you're trying to say. I'll give you an example. We're looking again at a budget versus the actual spend, let's say, right? You have a weekly budget and you think about how much you want to spend. So the budget is the dark line here, the actual is the lighter line. I can see the trends for each one of them, especially for for both of them. But my whole target in this case is to see if I'm on budget, under it, or over it, right? So I might want to use budget as a straight line, and the primary metric here would be the % difference compared to the budget. So I can know that in the 8th week, I was almost 30% under budget, so I didn't spend that much compared to what I thought about. And in the 17th, 18th week, I spent much more than I had planned. So think about these differences and make sure you choose the correct measure. Another tip is to use annotations in your charts, especially if we don't talk about dynamic charts or dashboards, right, where people can drill down and so on. If you just create a chart that you want to display somewhere and it's not interactive at all, try to use annotation if it makes sense. This is the database size over time, history and projection. And here I can highlight some special values, right, where we've seen, okay, so in 2017 we were at 5.9 terabytes, and we then ran archiving and got to 5.2. This way you can show the complete story and basically explain what the chart shows and the differences and the trends in the chart. Now, another thing is to be really careful with colors. Each color might have a different meaning, but what I'm trying to highlight here is not to get people tired while reading your chart. If you use emphasis colors all over the chart, it might be too much for them. It would basically give them a sense of alert instead of being really relaxed and reading your dashboard. So try to use colors found in nature in charts. You'll see that the people will, I mean, not necessarily the people, but even you will be more comfortable reading those charts. And use emphasis colors, like really vivid colors, only when you want to highlight something. You want to get people's attention to that specific thing. Now, we've talked about all the first 3 steps. You now have your chart, you've enhanced it, you have multiple charts, and you want to combine them into dashboards. I'll just show you here a couple of examples and why they were created the way they were. And we'll talk about interaction here because it's really important. Let's say we want to look at a website response time, right? How fast it loaded over time to see if we had issues or to monitor it every day to see if it's out of its target, or every week. Couple of things that I want to point out here. First of all, we have this line chart here, two major lines. One is time 50, or the median, and the other is time 90, or the 19th percentile. We're not using averages in this case, because the average would have been highly influenced by the outliers. So if we had 10 people getting a response time of 2,000 seconds for whatever knows what kind of error, it would have influenced our average, and it wouldn't have made sense. By using this, we can say, oh, okay, 50% of our visitors have a response time of under 2 seconds. 90% of them have a response time of about 4 seconds, or under 4 seconds, right? So you know it's under the line. I also have some reference lines here, which shows me the target for that year. So the target for that year was 2017, was to have 90% of the people having a response time of 6 seconds or less, with 50% of them having 2 seconds or less. So I can easily monitor this. In the bottom chart part, you'll see some KPIs. Basically, we have the pages split by type, because when you're talking about an e-commerce website, you have all kinds of page types, and we monitor them separately. Because each performance team is working on a different page type, and we want to see how much they improve the response time. This is the traffic, because traffic also influences response time. If you think about it, usually more traffic means a higher response time. In our case, more traffic meant a better response time, as caching was more effective. So whenever we had a 10% increase in traffic, we had a 5% decrease in improvement in response time. I can see the actual values for each page. I can see a comparison between with the previous week, with the 4 weeks average, so I can see a longer time period, and year over year. What you'll see here is that the usage of color is somehow different than you would expect. So whenever you have something up, it doesn't mean necessarily it's red or down green. We have a color threshold of 7%, because otherwise we say, okay, this is just noise. So we just want to highlight the pages that really improved or went worse. So we have this browse page here, when we see that versus 4 weeks, it went up 9%, and the following one, 11%. And again, the two metrics, time 50, time 90, which are the median and 19th percentile. This again was used by people who already know what the data meant and how to use it. So be careful with that. And now if I would have clicked on the deal page, the upper chart would have updated it to show only that. And you basically see now this everywhere. You have a dashboard, you click on something, it will filter the other views. It's the way to do it, because it allows you to interact with the data and find answers. Because one standalone picture might not answer you all the questions. Another example where the usage of color is strictly used for differentiating regions. So I can know the countries that are in each region. This is just for device monitoring. App adoption. How many people are using a specific app? Android, iPhone, iPad. The iPad slice is so small you can't even see it. Again, interaction to highlight what you're looking at. So if I click on Android and US, I can see the number of users there. Okay, so please try to make your charts as interactive as possible. Make sure people can find other questions, other answers to questions that you might not have thought about yet. Okay, that's about it with the learning part. Let's say hopefully you've found it useful. Now it's time to test your knowledge again to see if we evolved from the first test. If I remember correctly, the percentage in the first test was 41.6%, the average. Okay, let's see if we can do better. So open your phones again, please. Let's go. Same idea as before. I'm showing you a chart. Choose if it's used correctly, not optimal, or if it's not used correctly at all. Oh, wow, 75% of you got it right. So it seems we're on the right path. Hopefully we can keep it up. Funny thing about this chart, I'll spend some time explaining these charts now. Why people keep dogs in China, besides this answer here, which says to it, the usage of this chart is not correct at all. The sum of values is 195%. Why would I use a donut chart? Probably they thought about eating and used a donut chart. Why would I use a donut chart for showing something that it's not part of whole, right? It's not 100%. And that's the first thing I think about when I see such a visualization. Okay, the total is 100%. And I'm seeing here 93%. What the hell? Okay, let's go with the next one. Okay, let's see, 64%, this is looking really good. I'm starting to be proud of me, I might have learned something today. Okay, let's add that up. So, is this chart used correctly? I mean, the type of chart chosen is pretty good. It's a stacked bar chart. I can definitely see the trend. But then they thought about, okay, let's make this glamorous, or I don't know. And they thought about using gradients for colors. And they actually tell me here, see lots of orange, that's food and drinks. Okay, I see lots of orange here. How about here? Where is the limit here between the two gradients? Have I spent more on food and drinks, or whatever green means? I can't give a sense. And it's the same here. Why would you make a chart in a way that, okay, it might look nice, but it doesn't provide you any information? Okay. Let's go with the next one. Let's see. Oh, ouch. Okay, that might affect us, or might affect your average. And we'll need to do some explanations here. Most of you have said yes, but have you looked at the value here, which says 42.8, compared to this value here, which said 76.5? You haven't seen that. Okay. So what they did here, they've chosen the correct chart for showing this, but they've modified the axis without letting me know. You probably didn't even see it, right? And it's misleading. I'm saying that 76.5, whatever this is slightly better than 42.8. And this is actually a trick that you've seen on TV when talking about poll results or surveys. Whenever you had a candidate which had, 46%, the other had 40%, and they didn't start the axis on 0, so it might have seen that the one with 46% was doing twice as better as the one with 40%. You might have not noticed it, but your brain did. So it might influence the way you think, without even realizing. Next one. Most of you said it's not optimal. This is great. Some of you said yes. What have I talked about earlier with the pie charts? 3, 4 values at the most. This is a donut chart, I know, but the same rule still applies. Too many values, too many colors. Another thing, actually I've seen this chart on some paper regarding Bucharest Data Week 2019, and I was like, okay. If after Data Week you're showing me this kind of chart, what have you talked about there? Should I come and have a talk about data visualization? Again, really hard to tell the difference between the values, and the legend here is quite oddly used. if you look at this 14%, which is the second, you might think it should be here, but it's not, it's here. So we have an ordering like this, which doesn't make sense. Because these ones are closer together, so the space here between the rows is smaller than the space between the columns. So your brain will read these like this, and not like this. You can try to think about it. Hopefully we have one more question. Yes. Have I talked in vain for 1 hour and almost a half here? Are you serious? Is this a trend in time and they can't see it somehow? I mean, we're using the line chart, which is used for showing a trend. For categorical values, motor vehicle related, near miss, occupational health, and so on. It really doesn't make sense to use a line chart when you don't have a time dimension. Another thing is that your brain will see that these values are connected through a line, and it immediately thinks that these are somehow connected. But how is safety breach connected to security of organization property? It really doesn't make sense. Let me add this 23%. You screwed it at the end, you know? Why? Why are... Mm-hmm. Yeah. Just answer that. Okay. But it said yes. Okay, but good point. Okay, so at first we were, at the beginning, 41.6% first test. What do you think the average is now? Better? Worse? How many of you think it's better? Okay. We're better, but just slightly. We're at 45.6%, so we've increased with 4%. You've screwed it at the end. We were doing so great if just we had more correct answers here. Okay. Still, at least we improved a little bit. Okay, creative name 1. Okay, 4,000 points. Again, this was not the contest for the prize. Good job, Serena and Ioana as well. You're in top 3. Now, let's go for the contest. Again, you can receive a maximum of 1,000 points per correct answer, but speed matters. So the faster you answer to a question, the higher points you have. So you can get a maximum of 1,000 if you answer really fast, and then it will decrease. You'll have 45 seconds for each question. No, 30. We'll see how many seconds you have for each question. I believe 45. We won't go with the same example of is this chart correct or not. Some of the questions will show you just some data in a table and ask you what kind of chart would you use for showing that data. Others might be a little bit different. Use both what you've learned so far and common sense to try and answer those as good as possible. Okay, let's get started. 45 seconds per question. Did some of you start to use more than one mobile phone for answering? Because now I'm seeing 64 total results instead of 58. Okay, not nice of you. Okay, let's see the correct answer here. It's the line chart. Okay, 48% answered correctly. Okay, next one. Okay, time's up. Add labels and reference line. Really good catch, 80% of you answered correctly. I don't have an access here. I see that the percentage of males and females get closer and closer, but this might be 80, another percent, and I don't know how far are we from the target yet. Next one. Okay, time's up. Bullet chart. Okay, so we had the actual versus the target. It's what I've highlighted before. Just to make things clear, so we're talking about an A/B test. On the treatment, we have added this button here, which shows you how many items you have in the cart, and clicking on it allows you to get faster on the checkout page. Okay, 52% of you said it's percent of users who click on the cart button. But we're talking about an A/B test. I have control where I have no cart button, and variant where I do have. Of course, people will click on it more than on control, because here they don't have what to click on. So how can I compare these, right? A/B test results. Okay. The correct answer is actually two correct answers. You cannot either think of the percent users which make a purchase, so you know that adding that cart button allowed an easier process for checkout for the users. The whole purpose of an e-commerce site, when doing all kinds of changes, is to increase conversion. These two metrics define conversion. Another useful thing about having the cart button there is that I add something in my cart. I can come back the second day and I still see it there. Okay, let's look again. Maybe I might want to buy it. So these are the correct answers. Okay, time's up. Let's see. I've misled you on this one, I'll admit that. Box and Whisker are useful when you have all the data points. In this case, the results only show you these metrics. You don't know what each user did and how it behaved. In that case, indeed, if you would have the entire list of users who were in control in the variant treatment and see their conversion, you might have used the Box and Whisker. In this case, it's either a bar chart for comparing the test results or a bullet chart where you have the treatment as a bar and control as a mark. Okay, let's see the winner, Bogdan Pushkash. Bogdan, we have an issue there. We work at the same company. Second place, Roxana Pop. We work at the same company. We won't do that. Emilia G. Who is Emilia G? It doesn't matter. Come here. So here's your prize. It's a Chromecast Ultra. I mean, I believe you. Yeah, really good job. I mean, we shouldn't really discriminate. Nobody had any idea what this presentation was about. Yeah, I don't want to give you these prizes to you guys. I know we'll figure something else for you guys. Okay. Now, you also have a screen with the feedback on your phones. You can spend some time later if you want for filling that feedback. We still have 5 minutes left. If you have any questions or things that you think worth further discussing. Okay, probably you all want that break, right? Because it's 11:30 almost. Okay, thanks a lot for your attention. Hopefully you enjoyed this session. It was, let's say a little bit interactive. It's actually the first time I'm trying such a poll system, and it seems it worked pretty good. Okay, enjoy the rest of the conference. Thanks again for coming to this workshop. I know that maybe robots seemed more interesting in the other room. So I really appreciate that you came here. If you have any other questions or things that you want to discuss, I'll be at the stand, the Cognizant Softvision stand, until noon. So yeah, we can talk even more if you want to. Thanks again.